Hey guys, so we're looking today at present value tables in exercise 7D, and I've got the questions for you to have a go at there. The best way I thought this lesson could go is if I just gave you, this is actually a question out of the textbook, it's one of the example questions. The maths that you're going to do is actually nothing new from last lesson. So when we did the future value tables, it's the exact same mathematical skills. All they're doing now is talking about a present value rather than a future value. So we know a present value is what I've written here. This is what we know a present value is. So it's basically asking what amount invested now would give a future value of X dollars. And we know that that represents the present value. But what I want you to do for this lesson is think about the present value in a different way. Think of it more as, well, what is my present value now if I have been paying X dollars for N amount of months? That's the best way to think about your present value when we're looking at all of these questions in exercise 7D. So it's basically like asking, well, what amount of money do I have right now in this present time if I have been investing so much money at a certain rate every month or week? So, in saying that, let's have a look at this example question anyway. And if you want, the exercise does, if you're looking at this example question, is on page 287. So if you want to see it in a bit more detail, the answer, you can have a look at that page. Otherwise, I do want to go through it together. It says the table shows the present value of an annuity with a contribution of $1. So use the table to find the following. What is the present value of an investment of $500 per month for 2 months at 24% compounded monthly? So straight away, same maths we did last lesson. We have compounded monthly, means everything must be in months. So how many months was it? N equals 2 months. They told us that, so we don't need to change it. But R is 24% per annum. We need that in months. So that's as easy as, well, divide that up into 12, gives me 2%. So now in my table, I go, okay, 2% and N is 2, gives me 1.94. So my interest factor is 1.94, and it wants to know the present value of an investment where $500 was invested. So then my present value is going to be my 500 multiplying by my 1.94, which gives me an answer of $970. So again, then you would write a therefore statement. Therefore, the present value of this investment is $970. So it's the exact same thing as future value, but they've just named it as present value. You're going to do the exact same mathematics. So you can pause the video and give the rest a go if you want. Otherwise, I will keep going. So for B, it says, well, what is the present value of an investment at $7,000 per quarter for 1 year at 12% per annum? So straight away, I need to change my R and my N. My rate they gave me was 12%. And my number of time periods is 1 year. And again, I'm always going to write this on my answer and show my working. Okay, it's per quarter for 1 year. So that means they've going to invest 4 times in that year because it's per quarter. And my rate, if it's 12% per year, and I need to find what it is per quarter of a year, I'm going to divide that up into 12 and I'm going to get 3%. So now I go back to my table and I go, when N equals 4 and R equals 3, what is my interest factor? 3.71. Okay. All right. But it wants the value, so my present value which gives me an answer of 25,970. Okay. Next one, C. Find the payment or contribution per period of an annuity with the present value of that with 6% per annum compounded annually for 3 years. So the first thing I'm thinking, well, it's compounded annually. They've given me N is 3 and they've given me R is 6% per annum. I don't need to change anything. But this time it's asking it a bit around the other way. We need to find what the contribution was per year if it gave you that present value. So think back about the previous questions, think of it as like a formula. What have we been doing? In that formula, well, we've simply been multiplying the amount the annuity is by the interest factor. We've seen that before. So now let's think of it, okay? Sub in what I know. My present value this time is 33,240. And the contribution is what we need to find. So I'm just going to make that X instead of the $. And it's multiplied by the interest factor. I can work out my interest factor because N is 3 and R is 6. So N is 3, R is 6, 2.67. And again, it's one of those rearranging questions. I need what that X dollars is. What is that contribution? So I'm just going to divide 240 to give me that amount. And my X amount is going to be 12,449. And again, I would write a therefore statement saying, therefore, the payment or contribution per year is 12,449. Okay, and finally D. Find the payment or contribution per period of an annuity with a present value of $10,000 and 8% per annum, compounded biannually for 1 year. So compounded biannually, so that means half yearly or 6 months. So straight away, they gave me that N is 1 year, R is 8% per annum. And I need to turn both of these into biannually. So if they're looking at this charging interest biannually, that's twice in 1 year. And 8% per annum, and I need it for half a year. So if it's 8% for 1 whole year and I want to know what it is per half a year, it's going to give me an answer of 4%. So there's my rate, there's my N value. Go up to my table. And I get interest factor equals 1.89. So then straight away my present value is that money multiplying by my interest factor. Just going to skip a step. So that payment is going to come to 5291 to the nearest whole number. Okay, so hopefully you can see no new maths, same idea as our future value tables. It's really just about practicing that skill of, turning your N value and your R value into those rates you need them to be. And then just be familiar with the straightforward question versus the rearranging question. So have a go at those questions. I am happy, I'm just looking at the exercise now. Yes, you can definitely do every second letter. So I want you to do each one of those numbers, but yeah, they do get repetitive, so every second letter is fine.